Hello everyone, welcome to AI Anytime channel. In this video, we are going to develop a question answer generator app using Mistral 7B. So Mistral is a new large language model that has been developed by Mistral AI. They have released a couple of Mistral models in last 2 or 3 weeks, and that has surpassed a few of the other open source LLMs on different evaluation benchmarks. So I do have a RAG implementation video using Mistral. You can also have a look at that. In this video, we are going to develop this application that you currently see on your screen. It's doing something. It's processing. I will explain that. It's a question answer generator. Now, just imagine if you have a documentation or a manual or a rule book or a guide or a different knowledge bases containing PDFs or doc files. How can you generate either the question or the question answer pair? Now there can be multiple use cases in industries, like for example, if you are in education or academia, you can generate quizzes, questions, question answer pairs for your study, or you can also create it for your students, right, to automate this entire process of question answer generation workflow. And the other use cases can be, you have your legal documents, contracts, investigation reports, a policies document. How can you basically create a list of questions or a list of QA pair? Now I do have a video that I created, I think last month, on the same use case or idea, and this is one of the demanding use cases in the industry that I'm talking about. If you see that video here on my YouTube channel, it's called question and answer generation app using LLM, elevate your exam preparation. This is built on open source, sorry, excuse me, closed source model that does not excite me. uh, a closed source model, I really don't find much of interest in closed source models like Vertex AI models like Gecko or Text Bison or OpenAI, like we have Turbo or GPT-4. These models really don't excite me. So I do create some videos wherever there's no other alternatives. So I created this video here. You can see question and answer generator app using LLM. But if your data is really sensitive and if you want to create something in-house, how can you use an open source alternative of those models? And that's why we'll use the same app logic, but we'll use entirely open source stack. So we're gonna use Mistral 7B as a large language model. We're gonna use sentence transformers embedding models. We're gonna use Fast API that will help you create some API endpoints, and just will use that through Jinja 2 templates in Fast API on front end that you are currently seeing. And then we'll use LangChain as an orchestration framework. That's what we're going to do. Completely open source stack, nothing API is paid or whatever. Now, this is completely running on CPU, might take around a minute or two depending on the number of pages that you have in PDF. I have limited it to 5 because if the pages are like there are more pages in the PDF, you will also face some issues with the context token length that we have, right? That is supported by a large language model. So just to show you the logic and the use case idea, but you can extend this further depending on the infrastructure and need that you have. So if I show you in the terminal what's really happening in the back end, if you see it, it creates it. If you see it first goes inside some chains because we have some prompts, some refined prompts, and then it starts creating questions and answer. You can see the question one and answer has been completed. What year did leaders from 193 countries come together to face the future? It says 2015. That's where UN SDG goals were like where they started working, all the leaders from different countries in the United Nations, right? And you can see the second question: what were the leaders concerned about when they came together? Let me show you a result that I already have generated, just to save some time and start developing the code rather than talking. So if you look at this question and answer, so I have around 3 to 4 pages in the PDF that I'm currently using, and these were the question and these were the answer, guys. If you see what are the SDGs and what are their goals, then it talks about, let me just click here. Yeah, then it talks about, let me make it bigger so you can see it. It says the Sustainable Development Goals are a set of 17 goals established by leaders from nearly 170 countries in 2015. So we have the questions and the respective answer of that particular question. Now, this is very important when you want to fine tune some LLMs on question answering task or instruction tuned task, but you don't have a data set handy with you, but you do have a knowledge base. So you can use this app, just deploy it, make some logic changes or wherever required, and you can create your own data set to fine tune LLMs or even train LLMs, if you have the capability to do that. Now, how many SDGs are there and what are they? You can see the answer, perfectly nice answer, right? You can see the descriptions and all. This is what we're gonna have as an end product, once we complete this development. Let me just close it. I'm gonna save it for save it, like, oh, okay, let's don't save. Now I'll just minimize, and you can see it's happening. So this is what we're gonna build. You can see it has given you something probably for only two questions here, due to whatever reason, maybe due to context or sometimes due to producibility. But you can also have a reproducibility here by setting some seeds and all, and you can customize those inference parameter the way you want. So now let's start building it. So this is the app that you see here. We have a PDF viewer about the PDF. So you only have one page, guys, rather, or two page, if you also consider this some cards on images or something. So we have only two pages. So how many questions you can generate from a page or two, right? You can generate either three, four, five questions, and that's what we saw in the Excel sheet. Now, this is already available on my GitHub repository. So if you are not interested in watching the entire video, if you think that, okay, if you don't want to follow along, you can just go and basically use the GitHub code, the code from GitHub repository, and you can build it on top of it. But let's start building this app, guys, now. So to build this app, first thing that we need a large language model, and you can see the LLM that we're gonna use is the GGEWave format, that you can inference it on a commodity hardware like a single consumer GPU or a CPU as well. So the model is available on the block repo on the Hugging Face. You can find out this model. The link will be given in the description. So Mistral 7B, the instruction model. You can also use the OpenOrca model of Mistral if you want to have even better performance. Now, if you have a bigger PDF inside, like if you have number of pages, like 100 of pages, I will recommend you to use a model or an LLM which has a longer context, like Llama 2 7B 32K context by Together Computer. That I will give the link in the description as well. Both will work the same way. Now depends what we really want to do. Now this is my folder structure. I have a folder called Quiz App. Inside that I have two folders, static and templates. So templates nothing but just holds an indexed HTML. You can look at it, some bootstrap and JS code. This will be given, all of this code will be given on the GitHub repository. I'm not going to touch this front end thingy because I have already done in the previous video, but you can also like very much self-explanatory, if you see it. And then we have a static folder where we have two subfolders called docs. In docs, I will have my source data, the knowledge base, the PDF that we have, and then we have output. In output, we will save our output, the CSV file. It will automatically get saved. We just have to create this output folder name. Now in templates, we have one file. In statics, we have two subfolders. That's it. Now in requirements, we do not need Streamlit here. Let me just remove it. We do not need PyPDF because we're going to use PyPDF too. We are using fast CPU as an in-memory vector store. Then we have Python multipart, AIO files, because these are needed for fast API, because we are going to do a post request, because we're going to upload a PDF file, So you need a Python multipart and AIO files to handle those. Then we have Jinja 2 for front end templating, fast API as a backend, and they're going to rely, we don't need ChromaDB here. Let me just remove it. So these are the required dependencies that you need. I'm going to use C transformers to load the LLM, but you can also use Llama CPP Python if you want to use it. Now to build this, what we're going to do is create an app.py. So let's do it. Now in app.py, I'm using Copilot. It says press to ask Copilot to do something. I'm not going to do it. So what we can do is I can say from fast API import fast API, and then let's initiate an app. So I'm going to initiate my app here. This is how you initiate an application in fast API. And then next is I'm going to mount my folders here. So let's mount. So app.mount, and I'm gonna mount the static thingy here. So let's do a static, and you're gonna define a static file. So let's define that. I don't know why it's not showing. Okay, anyway, whatever. Static files. Okay, maybe I have not imported. So static files, and I'm gonna pass my directory. So directory, and then directory equals to static. This is my folder name. You can also change the folder name if you want. So static, and then what I'm gonna do is I'm gonna give a name static as well, just a label. Now this is how you mount. Now the next is have a variable called templates that we're gonna use it in our functions. So I'm gonna use a Jinja 2 template here. That though I am not. Let's Jinja 2 templates. And here we're gonna pass. Let me just do one thing. I have this import on my gist. I'm gonna open here Google Chrome, and inside Google Chrome, what I'm going to do is I'm going to open AI Anytime GitHub, and here inside GitHub, I'm going to go inside gist, and then I will have my imports. I already have the imports. Let me just do a raw and Control A, Control C. Come over here. I'll remove this because that. From Fast API, and then what we're gonna do next is so Jinja 2 template, and after that we're gonna define a directory here. So let me just do a directory, and inside this directory I'm gonna pass templates, and then so as you can see that we have linked our mount like the static folder and the templates. We're gonna load a model, so let's do that. So define load LLM. We're going to write a function, and here inside this I'm just going to use you can see it says C transformers T5 base, but this is not the model that we have. So let's change this model. So the model will be changed here. So it's the Mistral model. So Mistral, let's take it Mistral 7B, instruct. Let me just write it instruct, or let me do one thing. I'll just take the path from here. I'll just copy the relative path, and I'll just put it over here. That's the model that we have. And so C transformers, and not like that. By the way, this is, let me just copy this thing. It's Control C, hit enter, and inside the C transformer we have to pass a few of the param. So the first thing is model. So the model is now here goes our model, Mistral 7B model that we have. And the next is you have to pass a model type, and the model type is Mistral. So let me just do it. So Mistral is the model type, and after that what we're gonna do is the max new tokens. So let's do that. So max new tokens, and max new tokens, let's keep it as 1048 as max new tokens, and then we can have temperature. Okay, temperature, let's keep it as a smaller value of temperature, and then your return LLM. That's what we're gonna do here. So now if you see this, what we are doing here is that loading the model through C transformers, and you can use any other model as you want, and make sure that model is supported by C transformers. So if you look at the size here, the max new tokens, we are keeping it 1048, but you can also make the changes accordingly. Now here what I'm going to do is I'm going to create a function called file pre-processing or something, or let's call this file pre-processing, where I'm going to pass my file path as an input parameter, and then I'm going to write my logic. Now how we're going to load the data is, let's have a loader that is going to load the data, the PDF file that we have in the folder. So I'm going to do PyPDF loader. I'm going to use PyPDF loader. I'm going to pass my file path. So this is your file path that we'll use it later. Now the loader, let's have a variable called data loader.load, loader.load, Yeah, so this is going to load the question. Now let's have an empty ish. Let's create an empty string here, question gen. Okay, and now I'm going to say for page in data. For page in data, question gen, this is right. Question gen equals question gen plus page dot page content. Page dot page content. This is right. Okay, now this is fine. Now what I'm going to do next is we are going to create couple of uh, we have to initiate a few things here, so let's do that. So we need recursive character text splitter to get the content out of the PDF, the text that we have. So we need it twice, one for question and the other for the answer. So let's do it quickly. So we call it splitter answer gen, and here in splitter answer gen, or let's first do it for question gen, so keep it in order. So splitter quest gen, in this I'm going to use a recursive character text splitter, not a recursive error by the way, recursive character text splitter, and inside this we can define our chunk size and chunk overlap. So let's do it. So I'm going to define a chunk size. So first chunk size equals, let's keep it 1000 for question gen. Like look at the first 1000 tokens, the chunks, and then create your questions out of those first chunk, because this is becomes one document. Now then it goes chunk overlap, that let's keep it a chunk overlap, and the chunk overlap can be 100. So let's do it. Now splitter question is done. Similarly, what we can do is, by the way, let me just do a control G here. I'm just going to copy it, come here, space, paste, and I'm going to do it for, let me just do that. Let's call it answer gen now. So splitter answer gen. This is what we're gonna do. Let's write it. Okay, so for answer, let's keep it fine. Let's make it a little smaller. Maybe we can 1000. Let's keep it for answer. Look at the next. Let's call it 500, and then reduce the chunk overlap to 50. Okay. Now we have these two ready. So now what I'm gonna do next here is, so these are two of our splitter question gen and splitter answer gen. But what we have to do also is to, let's call the chunks. So I'm going to call it chunks question gen, question generator, and inside this chunk we're going to have a splitter. So splitter question gen that we have dot split. But let's use the split text function. So I'm going to use the split text function, and then this looks good. So this is fine. Now after this, document question generation. So document question gen, and let's create a document for all of this chunk, all of this question chunk. So I'm going to call it document, and then goes your page content. So page content and equals t for t in chunks question gen. This is right. So this is done. Now similarly we do for answer generation as well. So let's do it. So document answer generation, answer gen, and here I do it for splitter answer. Let me just use splitter answer gen dot split documents. Yes, split documents, and here I pass the document question generation. Fantastic. Now here just want to return this. So let's return both the document for question and answer. So return document question, excuse me, and document answer gen. Fantastic. Now this function is ready. Okay, now we're going to define our LLM pipeline here, guys. That's it, what we're going to do here now. So let's define an LLM pipeline. So LLM pipeline, and inside this I'm going to use my file path, and then document question and document answer gen. Then it took your file preprocessing, file path, then LLM has been load. So let's call it little more explanatory. Let's call it first question generator. So LLM question gen pipeline, because we have to call it twice. LLM question pipeline load LLM. I will just return this. We need a prompt template here. So let's use a prompt template variable. Let me see if I have that in my gist. So what I'm gonna do is let's go back here and see if we have something in gist. So let me see. We're gonna have input. Okay. So let's copy this prompt template. I do have a prompt template, but we have to make some changes here in the prompt template. Now let's copy here and remove, and that's it. So we're gonna make some changes in the prompt template. So it says, if you look at here, it has a prompt template called "You are an expert at creating questions based on coding materials and documentation." Let's remove this coding materials. We call it based on materials and documentation. Your goal is to prepare for their exam and coding test. You do this by asking questions about the text below. Let's remove this entire thing. Your goal is to prepare a set of questions. So let's use it like this. Prepare a set of questions. This is better. You do this by asking questions about the text below. The text goes below, and then create questions that will prepare the code or program for them. Prepare questions makes you create questions that will prepare. Let's remove this. Let's create questions that will prepare the end users. Make sure not to lose any important information. Then goes your questions. Then we have prompt questions. And in the prompt questions, we're going to use the prompt template that we have defined above. Input variable is your text. And then we have a refined template. It says you are an expert at creating practice questions based on. So let me remove the practice here. Based on material and documentation. Your goal is to help a coder or programmer prepare for coding test. We do not need it. We have received some practice questions to a certain extent. Okay, this is an existing answer. We have the option to refine the existing questions or add new ones, only if necessary with some more context below. Give the new content in English. Help provide the original question. Okay, this is fantastic. Now we got our refined template. Now, so what we're gonna do next here is let's refine. So refine. Gonna use refine prompt template. So let's call it refine prompt templates. And in this templates, what I'm gonna do, or let's don't call it prompt templates. Let's call it refined prompt questions. That will be more explanatory. Now these will be the refined prompt questions that has been generated. So here I'm gonna use the prompt template again, and in this prompt template, so let's use our input variables. So our input variables, now our input variables will be both the existing answers. You can see it over here, the existing answer and the text. Those will be our input variables now. So let's use those exist answer and text. So let's existing answer and text. This is our input variables, and then we'll have a template, and this template is nothing but the refined template that has been defined in line 86. Now this prompt questions is also ready. Now we are going to write a generation chain. So I'm going to call it question chain. So let's use a question chain, and in this we need a summarize chain, because we have to also take care of the number of tokens that we're going to work with. So let's use a summarization chain, and in this load summarize chain, the first is LLM, and our LLM is nothing that we have used above here. You can see it's called LLM question chain pipeline. So let's call it, so I'm going to call it question pipeline. What was that? LLM question pipeline. So that is LLM question pipeline. This becomes your LLM. The next is chain type. Let's have a refine chain type. For summarization, you should use refine. If you're QA, you can use stuff and map re-rank. Now, type, let's have a verbose equals to true to keep a track of those things in terminal as well. Now, your question prompt. So let's call it question prompt, and your question prompt is nothing but the prompt questions. And then you also have a refine prompt, and then refine prompt is nothing but that goes your refine, excuse me, that goes refine prompt questions. So we have created a chain now for generating the question. Excuse me, question generation chain. Now what we're gonna do next is we're gonna create a question here. So variable question. So question chain that we're gonna use and going to run it over the document that we have that return only on the question document. So document question gen to generate the questions. Now this question has been generated. Let's create the embeddings. So let's have a variable called embeddings. We're gonna use the hugging. What is BGE? We're gonna use Hugging Face embeddings. Let me see the imports by the way. Looks something wrong in the imports. Fine. This is Hugging Face embeddings. Now we have now gonna use the sentence transformer model here, guys. So Hugging Face embeddings model name, model underscore name, and that goes your sentence transformer. Okay, so let's use the MP-NAT by the way. Sentence, I don't know why I used capital, that should be small. Sentence transformers, and you're gonna use the MP-NAT version 2 model. So let's call it sentence transformers all MP-NAT. Excuse me. Yeah, all MP-NAT base B2. This is a embedding model we're gonna use. Now, once you have defined the embedding model, we're gonna create the vectors and gonna store it in a vector store. So we're going to use FAS here. So let's call it a vector store. So vector store, excuse me, not capital. Now vector store, and this vector store is nothing but come from FAS, and the FAS from document. So let's call it FAS from documents, and here we're gonna use our document answer gen and the respective embeddings. Okay, so that embedding that we have defined on top. Now we're going to generate the answer using an LLM. So let's call it a variable called LLM answer gen, and we're going to use the load LLM here for answer generation. Question we already have done on top. Now LLM answer gen. So here let's create a list. So question list, and I'm going to split it. So question split that we have on line 114, question split, we're going to split it on a line break. Okay, creating a list of questions. Now let's have a filtered question list. Filtered question list, and inside I'm going to use an element for element in question list if element stripped. Not exactly I need that. Okay, so question list if element dot ends with, I need a not strip, ends with. Yes, ends with question mark. This is right. And now I can say or element dot ends with dot full stop, not this, full stop. So let's give that by the here it will be full stop. So let's do that. So let's give a full stop. Okay, so this element thingies are done also. Now let's create an answer generation chain now, guys. Okay, so answer generation chain. So question generation chain we already have. Now we are doing for the answer. We're gonna use a retrieval chain here. We're gonna retrieve the answers. So let's use the retrieval chain. So I'm gonna use retrieval QA from chain type. And here I'm gonna pass all of my thingy. So the LLM is going to be LLM answer gen that we loaded again from C transformers. You can use any other model that you want. We are using Mistral 7B or Mistral. I don't know how to pronounce it in French accent. Chain type, we're gonna use the stuff for question answering. That's what recommended by LangChain. And I'm gonna use the retriever. So our retriever is going to be a vector store dot as retriever. As underscore retriever. Okay, as a retriever. Fantastic. And now let's just return both of these things, filtered question list and the answer. So what I'm going to do is return answer generation chain and the filtered question list. Fantastic. Now we are done with the backend thing, guys. So far what we are doing, we have this is our backend logic for the LLMs and all. Okay, so now we have some utility thing to do that we'll mostly copy. Now what we are doing here is we are initiating our app, mounting it, have written a function called load LLM that will load your Mistral model, and then we have file pre-processing. We are creating a list of questions, some Pre-processing modules like recursive character text splitter for both questions and answer to split it, create a document out of it, and then return it. And then we are having a couple of prompt examples, prompts. For one, we're calling it refined prompt questions. Then couple of chains, creating embeddings, storing it in an in-memory vector store, and then using some chain to generate answer, which is a retrieval QA chain, by the way. Now, this is right. So what I'm going to do is let's write a function called get CSV that will help us to get the CSV, from uh, file path. So let me just do it. Okay, so get CSV, and here what I'm going to do is I'm going to use my answer generation chain. So answer generation chain and question list. So to LLM pipeline file path. So here I'm going, because we're going to return that to the end user, right? Now I have a base folder. So let's define a base folder, and in this base folder I'm going to write, this is my base folder, static, and inside static we have output folder, and that's it, a subfolder. Now this is your base folder. I'm going to say if not, okay, os.path.is directory, os.path.is dir. If os.path base folder, then you make that directory. If there is no such folder, you first create it. Okay, now let's come out of it. Now what I'm going to say is output file, we'll write it later, output file, and then that is going to be base folder plus output.csv. Okay, let's call it output.csv, or rather I am using qa.csv, so let's call it qa.csv in that case, just if you want to use the same code. Now qa.csv is that your output file. Now again the logic goes new line encoding and all you have to define. So let's do it with open output file new line. This is right. I also need UTF-8 encoding. So encoding UTF-8. Let's define it. So UTF-8. That's what I'm going to do here. UTF-8 as encoding, and let's call it as CSV file to make it self-explanatory. Now here we're going to have a, let me just remove all of this for now. Okay, so we're going to have a CSV writer, and then I'm just going to write that CSV file. So that is right, and then write row. This is right, question and answer. This is fantastic. Now what I'm going to do is, see, this is the power of GitHub Copilot. Now for question in question list, I think this is right. So for question in question list, we're going to use the answer generation chain. Okay, so maybe you can also print it, but this is fine. CSV writer dot write row. This is what you're going to write it. And now next is CSV writer dot write row question and answer, and then let's come out of it, and I'm just going to return the output file. Fantastic. So this function has also been written, guys. So here what we are doing is, we are basically taking care of the Excel sheet, the CSV file that we saw. Now I'm going to use, now we're going to use some decorators, some APIs like an endpoint, going to make some request using fast API, and this is right. So I'm just going to use this here, async def index request, and I'm just using the Jinja 2 template and just returning it, template response, and then just do it. Now this decorator which is a get request has been done. So now what next is to create a post request where we will have upload. So let's do it, app.post upload as it is, whatever it's showing. Now here let's create a function called async def. Okay, let's call it, for example, uh, async def chat or something, whatever. Okay, whatever name that you want to give, or let's give async def upload. So upload, and then here request file. So request PDF file bytes, and this is right, I think. But anyway, let's have a form kind of a thing. So request, this goes request, not exactly what I need. Request PDF file, and then PDF file is your file, and PDF file, and then I have a file name. So file name, that is going to be a string, and that will be a form. So let's use a form. Fantastic. Now form, so this is okay. Now I'm saying let's remove, I don't need all of these things for now. Okay, so I'm just going to say base folder, and the base folder is going to be static, not uploads, the base folder is docs. So base folder is docs. So the docs is fine, which is the folder. Now again the same thing. If that is not the directory, then create the directory, and then I'm going to give it a PDF file name. PDF file name equals os.path.join and the file name. This is right. Okay, base folder. This is correct. Now I'm gonna use an async function by using AIO files, which is what's currently showing. PDF file name dot does as out file. This is right. So let's use that content. So what I'm gonna do here is content await PDF file dot read. Okay, await PDF file dot read as out file. So I'm not gonna read. I'm gonna write. Okay. So as out file as file, PDF file name as file. I'm gonna use await, and then yeah, this is what sort of I'm looking at. So let's call it f dot write, and then just the PDF file. Okay, so this will do. And then just gonna have a response data. So let's have a variable called response data. And here in response data, I'm gonna use a JSON-able encoder to get the output in a beautified way. So JSON-able encoder is a function. So I'm gonna use JSON-able encoder, and I'm going to say JSON.dumps. And inside this, I'm gonna again, this is a function. We can define a key value pair. So message, I'm gonna give it success, for example, and then you have your PDF file name. So PDF file name is PDF file name. This is right. And then just have, let's for example, get the response perfectly fine. You're gonna need application JSON here for now. You can just do response data. But if you want to write better code, you should follow it, right? Status code and all, and then just return the result. So this is what our function is. Now we have the last function, the last endpoint. Let's call it, it's fine if you call it generate. You can also call it, let's call it analyze, because then I have to change it in my UI as well. That's the endpoint that I'm using. Now analyze, and in analyze, what we're gonna do next is, let's have an async def. This looks nice. Async def analyze, and so async def analyze request to request PDF file name. This looks good. Output file as get CSV PDF file name, then response data as JSON enable encoder, blah blah blah. And here is output file as output file, and response data return result. This is right. Now in below, what we're gonna do is we're gonna use name main and run it as uvcon dot run, and we can run it as app:app. So you can also run it through Python if you want. Host, let's use it 0000 localhost, and then port 8000. So this is what the port runs on, 8000. And then you can keep reload equals true, just to make some changes. So now we are done with our code, guys, on the front end. I hope you understood what we have done so far. So if you look at the endpoints, this is the first endpoint that will redirect to this template. If you do localhost 8000, if you do localhost 8000 slash docs, it will also take you to Swagger UI. Now here in this function, what we are doing is, we are first creating a folder if there is no, but if there is folder, it will not create. And then what we are doing, just calling the function that we have defined on top, the function that we have used here. And you can see response data. Okay, that's the thing. Now what we are doing here is def analyze to response data. Fantastic. Now we are done with our code, guys. So we'll run this and see if we are getting the same response that we are getting earlier. So now let's run this this application, guys. Let's open our terminal here that we have. I don't know why it still say. Let me just close the terminal and go back here, and quiz app. I'll go inside quiz app, Open in terminal. I have to again go inside venv scripts dot slash activate velocity dot dot couple velocity dot dot clean. Let's do a python app dot py. Now once I do python app dot py, I'm expecting that it will say, it runs on localhost 8000. So let's go ahead and run it on localhost 8000. Let me make it bigger and I'll just do localhost 8000. Now, once I do localhost 8000, you will see the same UI now, the front end that you saw in the beginning of this video where we were running some, like some process. You can see this is the PDF file. I upload the PDF file and it will take a few seconds up to minute or as well, depending on how big the PDF is, how many pages are there in the PDF. So we have a less number of pages, but it will take up to a minute something. So let me pause the video and I will come back once it gets completed. So you can see we got our result. Now we can see a PDF viewer where we have only one page. You can see the only one page is there, which has some text, which is little verbose, and from that we are generating the both question and answer pair. Now once I click on this Excel sheet like this download, it will download a CSV file having a questions and the answer pair. And you can also track it here in this finish chain. You can see it says, in what year did leaders from 193 countries come together to discuss global problems? And you can see the result. It's a summarized chain that we have used for question thingy. If you look, go back to code here quickly, you will see the chain that we have used. For question generation chain, we have used a load summarize chain, and for the retrieval, we have used answer for we have used the retrieval QA chain. Now, this also varies the way you chain this value. So we got so sometimes you will get three questions, sometimes you will get two questions pair, like QA pair, depending on the way you are uh, pre-processing your PDF file. So right now I only have one page in the PDF. That's why only you can see couple of QA pairs, but you will have more. So you will have a more question and answer pair. You can see the second question was what specific problems that were common to various countries and communities around the world were addressed by leaders during this meeting. It says in the year 2015, leaders from 193 countries of the world together to face the future, and what they saw was daunting famines, drought, wars, plagues, poverty, etc. So if I show you, I do have this QA pair that I generated. You can see it's for this it generated five questions, and sometimes it generates five, sometimes it generates three. Maybe you can use seed or something for reproducibility if you want, and you can increase the token size as well, the number of tokens limits that you have. So this is what I wanted to do in this video, guys, to show you that how you can build an app that will help you generate QA pair, the question answer generation question answer pair using entirely an open source stack that will run locally on your compute limited uh, CPU or GPUs, whatever you have. Even if you have a single GPU, you have to make changes here in the GPU layers, like here in the C transformers. After that, they have a number of GPU that you can pass. Okay, so number of GPU layers, by the way, not number of GPU. So this code will be available on my GitHub repository. You can go ahead and just take the code from there and extend it further. If you have any thoughts or feedbacks, please let me know. If you have any questions, please drop your questions in the comment box. You can also reach out to me through my social media channels. Okay, if you haven't subscribed the channel yet, please do subscribe. Please like the video and share the video and channel with your friends and peers. Thank you so much for watching. See you in the next one.